Class quadratic means to the power of 2. That's why I'm putting 2 on my chart. Explain how to determine the number of solutions, or another word for solutions are x-intercepts of f of x given the graph f of x given the graph. So let's talk about the 3 examples we just did, C, B, and A. Let's look back. In group C here, we had the number of reals was 0 and 2, 0 and 2. Yes? So the number of x-intercepts were 0. That tells us the number of reals where it didn't cross. And if I look at these 2 boxes here, in group C we had 2 imaginaries, so 0 plus 2 equals 2. How about group B? How many x-intercepts do we have? In that one we had 2. Well, it looked like it has 1, right? It touches the x-axis once. Do you see that? We can write a 1 here. But we knew that it has 2 reals plus 0 imaginaries, and that equals 2. So I'm kind of looking at this box right here to see that they add. Let's do group A now. In group A, how many x-intercepts were there? There were 2 x-intercepts, 2 dots. And then, how many reals did we have? We had 2 reals. And if I add that to the number of imaginaries, how many imaginaries do we have? 0. That equals 2. And basically this explains the fundamental theorem of algebra. What is that fancy thing? It basically says if you looked at this problem, someone recognized they were all quadratic to the power of 2. So basically the degree equals the real plus the imaginaries. So you're always going to have, that number will tell you how many x-intercepts you're going to have. The question is if they're going to be real or imaginary.